Thanks for watching the screencast. If you're watching this screencast, you've already played with the Desmos page that you were sent on Google Classroom entitled Slope-Intercept form. So here is one specific instance from the Desmos page that you used. You played with the sliders that changed the values of m and b. And in this particular instance, if the equation is y equals m times x plus b, if m is 3 and b is negative 2, what you're looking at here is a graph of y equals 3x plus negative 2, which we can just write as minus 2. This is y equals 3x minus 2. But what I hope you noticed from playing with m and b is that b always coincides with where the graph crosses the y-axis, right here. If you changed the value of b, you would see the graph of the line essentially moving up and down the y-axis. What m affects, and actually decides and determines, is the slope. This number 3 here also means that the graph has a slope. If you think about rise over run, again, if you think about going up 3 and right 1, you would say that the slope is positive 3 over positive 1, which is just 3. So here is the rule that you discovered in Desmos. We call this slope-intercept form. A linear function is in what we call slope-intercept form if it can be written as y equals mx plus b. Mx means m times x, where m is the slope of the linear function, and the point 0, b is the y-intercept of the line. So here's an example of a line, and if we were asked to write the equation of the line in slope-intercept form, we could try to pick out, based on the graph, what values m and b must have. So I look at the graph and I see that it crosses the y-axis at 4, and that tells me that b should be a positive 4. If I ask you to find the slope of the line in the graph, I would maybe start at this point and decide that I want to go from this point to, how about the point 1, 2? And in doing so, I would say, well, I need to go down 2 and then right 1. And that means that my slope would be negative 2 over positive 1, which is negative 2. And now I can use these values in this equation and write the equation of the line. Y equals, if m is negative 2, this should say negative 2x. And if b is 4, it should say plus 4. So there is an equation for the line in the graph. Let's work through a couple more examples like this. Here's an equation of a line given by its graph, and what we want you to do is to write the equation. This linear function graph crosses the y-axis at negative 1, so b is negative 1. To find the slope, I could use any 2 points. I don't have to start at this one, but it might be convenient to. Just to show you that it doesn't have to be that point, I'll do it up here. I'll use these 2 points to find the slope. If I start here and go up 3 and right 1, then the slope is positive 3 over positive 1, or just 3. And now I can use m and b to write the line equation y equals 3x minus 1. Here for this example, the line that we're trying to write the equation for appears to cross the y-axis at 3. So that'll be my value for b. I need to find 2 points to use to find the slope here. Maybe I'll use this one and 5, 1. So here I need to go, looks like I need to go down 2 and right 5. So my slope, rise over run, is -2 over +5. The two signs being different means that the slope will be negative. Nothing divides out of both 2 and 5 other than 1, so I can't really reduce that fraction. It's just -2/5. And knowing the values of m and b, I can write my equation y equals -2/5 x plus 3. Okay, you know what to do. Pause the video, try to write the equations of these two lines, and when you think you've got answers that make sense, hit play and get some feedback. This first line graph we're looking at crosses the y-axis at -1. So I know that b will have the value -1. If I think about finding the slope, I need to find a couple of points to use. I'll use this one and 3, 0. And I'll see that I need to go up 1 and then right 3. So my slope would be +1 over +3, which is just 1/3. Two positives make a positive answer, and 1/3 does not reduce. So my line equation is y equals 1/3 x. If I wrote plus a -1, that would be okay, but we may as well just write that as -1. Y equals 1/3 x minus 1. This second example crosses the y-axis right at the origin, right at 0. So the value b will have is 0. To find the slope, maybe I'll use this point and this point. I'll say I'll start here. I'll go down 4 and then right 1. So with a slope of -4 over +1, you know that's just -4. So I'll use the values of m and b to write my equation y equals -4x plus 0 is an okay thing to write for b. Now, we don't usually write plus 0 in the line equation if plus 0 is what the y-intercept would make it. There's nothing wrong with it. It would get full credit. It's correct. But it's kind of math cool to not write the plus 0. So maybe it would be good to shoot for just writing y equals -4x. So here's a different flavor of the same problem. Here's a problem where I'll give you the equation and you make the line graph. Well, if we want to make a graph of y equals 2x minus 3, it might help to think about the fact that, you know, this value here, the number multiplied by x, is my slope, 2, and my y-intercept is the number in the right side of the equation not multiplied by x, -3. So to make the graph, I want to think about maybe making my first point happen at the y-intercept. b equals -3. Maybe I want to put my first point right here. Now a slope of 2, if I want rise over run to be 2, I need to think about a fraction maybe that means the same thing as 2. And I can pick any fraction that means the same thing as 2, but I usually want to try and find the simplest one. Let me think about maybe 2 over 1. And think about rise over run. What this means is from the point I already graphed at -3, I could have a rise of 2, I could go up 2, 1, 2, and then a run of 1 right there, and plot another point. And that pattern can continue. I can do that over and over again to find other points on the line. I could go from this point up 2 and right 1, and up 2 and right 1, and up 2 and right 1. And we really like to see you fill the whole space with that pattern as best you can. I could even go work backwards. I could say, well, where would the previous point have to be? I guess it would have to be down here, because then I could go up 2 and right 1 and so forth. And then go through and hit that, connect that with a line. There's a good graph of our linear function y equals 2x minus 3. Here's another example. y equals negative 2/3 x plus 4. Here my slope is negative 2/3. You know, if the slope is negative, you're going to have to decide whether or not to make the negative part of the rise or the run, and I always suggest you do the rise. So let's think about the slope as negative 2 over positive 3. Let's think about a y-intercept of 4, and let's see if we can make our graph. Our graph should have a y-intercept of 4 right here. From that point, I should be able to go down 2 and right 3. Down 2 and right 3. And I can do it again, down 2 and right 3. I can even go up 2 and left 3 to hit that pattern as well. And all of these points and everything in between represent that linear function. So there's a pretty good sketch of that function. Okay, once again, you should pause the video. You should try to make these linear function graphs. And when you've got answers you like, hit play to get some feedback. To graph y equals 4/3 x plus 1, I'm looking for a slope of 4/3. Rise over run. And the y-intercept, the place where this line will cross the y-axis, is positive 1. So, on the y-axis at 1, I need a point. From that point, I need to think about rise over run. I need to go up 4, 1, 2, 3, 4, and right 3 to right here. Up 4, right 3, and 3, 5 should be on the graph as well. The next point that hits that pattern is off my graph, but I could go back and do it backwards. I could go down 4 and left 3, and that point should work too. And the next one's going to be just a little bit off the graph, but we'll go ahead and make it 2. So this linear function should look something like this. Here we've got, for y equals negative 2x plus 5, we've got a slope of negative 2. And we've got a y-intercept of 5. So again, here I need to think about writing a fraction that means the same thing as negative 2. And the simplest option I think you could use is to just simply take negative 2 and divide it by positive 1. So I'll think about rise over run this way. I'll make the y-intercept happen at 5 on the y-axis. From that point, rise over run, I'll go down 2 and right 1. And down 2 and right 1. And down 2 and right 1. And I'll do that, I'll fill the whole space in the graph that I can. And then I'll connect it all with a line. Remember that lines go on forever, so you should draw arrows at the end. There it is. It's time for you to try this on your own now. Thanks for watching.